Hi, my name is John Paul Raj, and I'm on a mission to make the learning of math fun. So if you're new to this channel, please do consider subscribing. On this particular video, we're going to take a look at how to solve some problems, which is a combination of the chain rule and the quotient and product rule. So let's find out how. The first example we're going to take a look at is y is equal to log to the base e, which is ln, ln some people say. It's a natural logarithm actually. Log to the base e of, into the brackets we have x times sine of x. So you can see that it's a composite function, right? Log of another function inside. And that composite function, there's an inside function and an outside function. That outside function is log, the natural log, and the inside function is x times sine of x. And what's different about this particular question is that that inside function is a product of two functions, x times sine of x. Can you see that? That is x times sine of x. So as such, because it's a composite function, log of another function, we are going to use the chain rule. But to find the derivative of the inside function, we have to use the product rule. So that's a nice combination of the chain rule and the product rule. So let's see how to do it. The first thing I would do is, so that to keep it clean and simple, I would introduce a new function. Let's say let u be that inside function, x times sine of x, just so that it's clean and neat. You can even avoid this step. You can just go directly to differentiate, but this is just to keep it neat and clean. You might want to use this step. If you don't like this step, just go ahead and do it directly, okay? Nothing wrong with that. Use that product x times sine of x. So when we differentiate with respect to x, let me use another color, differentiating u, WRT stands for with respect to x. Now that's a product, right? So we are using the product rule to find du over dx. On the left-hand side, it's just du over dx. On the right-hand side, we have got that product x times sine of x. How do we differentiate using the product rule? Well, the derivative of the first term, x, the derivative of x is 1, multiplied by sine of x remains as it is, the second term, right? Plus, don't forget the plus sign, okay? First term remains as it is, x. The derivative of the second term, derivative of sine is cos of x. Can you see this? All right, now just simplify that and we will get our derivative as sine of x plus x times cos x. This is the derivative of that u, just that u that we have introduced. Our original function is actually y is equal to log to the base e of that u. We introduced u, right? So let me just write that with that color. That was the original function. Now, the derivative, if you were to just differentiate this one with respect to x, we'd say differentiating with respect to x. On the left-hand side, you'd get dy over dx. On the right-hand side, it's the derivative of the natural log of u. You can directly say that's going to be 1 over, we'll use u times du by dx. That's chain rule. Why did we do that? Because it is 1 over u and u itself is a composite, okay? It's a composite function, so it is 1 over u times du by dx. Now we've got these values, right? We've got these values, we just substitute back, okay? U was x times sine x. That would give you the final value as, final expression as 1 over x times sine x, x times sine x, times du by dx is sine x plus x cos x. I wrote these things separately because, so that it's organized and you can understand what's going on, but you could have directly jumped and found out dy by dx, differentiating both sides directly and said that, dy by dx is just that outside function, derivative of the outside function. Log function is just 1 over that term, okay? That inside term should remain unchanged, remember, the inside function. So it's just 1 over x times sine of x multiplied by the derivative of the inside function. You could have directly done that. This is just to keep it neat and clean. So now I can just, combine these things and write down the derivative here because I've got the second question there. I can say dy over dx. Did you see this? All right. I'll say that's the numerator sine x plus x cos x, sine x plus x times cos of x divided by x times sine x, x times sine x. So let's just quickly recap what we did do. We had y is equal to log to the base e x sine x. We recognize that it's a composite function, right? Log, and then there's another inside function, but that inside function is a product. So what did I do? I introduced a new one. And like I said it, earlier, you need not do this. You can directly go ahead and differentiate if you're comfortable doing that. But if you are the first time you're doing all this kind of stuff, maybe it's good to just write it clean and, your algebra will not get messy. So you can say u is that inside function. That inside function was a product. So you can differentiate u using the product rule. That's what we did. So the original function y is just basically log to the base e of u. And remember, that's a composite function, all right? So when you differentiate it, you're using the chain rule. The outside function is log, so we just write 1 over u. And using chain rule means it's not just 1 over u, you're multiplying that by du over dx. Once you've set it up, you can just, substitute, whatever you had originally done for u. U was x times sine of x. I did that 1 over x times sine of x multiplied by du by dx. We got that expression here. Put it all together algebraically, and you get that final answer for dy by dx. All right, let's take another question with this kind of a combination of chain rule and the quotient rule. Look at this question. This is a quotient rule. Okay, at the outset, it's a quotient. But the quotient, as you can see, if you identify a u and v, the numerator is cos of 2x. That's a composite. It's not the direct rule of cos of x. It's a composite. This is cos of 2x. And the v is e to the power of 1 minus x. That's another composite. Isn't it interesting? The first question was a composite function, and within that composite, that inside function was a product. But in this question, the original function is a quotient of two different composite functions. So I thought it would be interesting to see how to do the combination of the product rule, the quotient rule with the chain rule. All right, so let's go on with it. We've identified u and v correctly. And as I said, these are composites. Okay, the numerator and the denominator are composites. As such, when we differentiate, this time let's go directly, okay? You can say du over dx would be negative sine 2x times a 2, all right? You can see that, and I'll explain it along the way. This time I've not substituted, okay? So as I said it before, you don't need to do that substitution. That just helps you keep it clean and organized. So let me explain this differentiation. Cos is the outside function and the inside function is 2x. So u is a composite function, cos of 2x. It's not the same as the direct rule for cos of x. The derivative of u, du by dx with respect to x, that is, would be negative sine, derivative of the outside function, negative sine. Inside remains as it is. 2x remains as it is, okay? So negative sine of 2x multiplied by the derivative of the inside function. The derivative of 2x is 2. So when you simplify this, to get the derivative of du by dx, you'd get negative 2 sine of 2x. All right. In the same way, let's try what is the derivative of v. All right. So let's write v is e to the power of 1 minus x. dv over dx would be the outside function is e to the power of something. And the inside function is that something 1 minus x. So the derivative of the outside function is still e to the power of that same term remaining unchanged. The inside function remains unchanged, multiplied by the derivative of that inside function. The derivative of 1 minus x should be a negative 1. I'm doing this question without that substitution that we did in the first question, all right? That was just to make it simple, but eventually, like I said, with enough practice and knowing how to use the rules, you will be able to do this kind of differentiation, okay? Trust me, with enough practice and knowing your algebra, you should be able to do this kind of differentiation. Now, this is just the derivative of the numerator and the denominator. Remember, the original question was y is equal to cos of 2x divided by e to the power of 1 minus x. We found the derivative of the numerator. We found the derivative of the denominator. Now we have to use quotient rule because that was the original function. The original function was a quotient of composite functions. So dy by dx, dy over dx, using quotient rule, the derivative of the numerator is this one, okay? Negative 2 sine 2x, negative 2 sine 2x multiplied by v remaining as it is, e to the power of 1 minus x, minus, okay, quotient rule has a negative sign, minus the derivative of the denominator, which is a negative e to the power of a 1 minus x, times the numerator remaining as it is. Numerator is cos of 2x, cos of 2x. Can you see this whole thing? All right, need to adjust that. Okay, divided by, don't forget that divided by the square of the denominator. The denominator was e to the power of 1 minus x. And let's just square it up. E to the power of 1 minus x, the square. Sometimes at the time of the exam, we forget what the original question is because we've differentiated 2 times. And that was, chain rule. And the original question actually is a quotient rule, the quotient of the chain rule. So sometimes when we differentiated a few times, we forget what the original question was. So, check your work, and, if you've laid it out properly, you need to understand, well, this is the final answer. You got to put the derivative of the numerator, the derivative of the denominator, and utilize the quotient rule. But this is not yet complete. Let's simplify this and find out what the final answer should be. So this is, I can actually factor out that e to the power of 1 minus x, there's a denominator that can get cancelled. So you should get an, let's write it as e to the power of 1 minus x. On here we'll get negative 2 sine of 2x. And this is a plus cos of 2x. The denominator, we've got e to the power of 1 minus x, and their factor of that, square of that. And so that one term can be cancelled off, so that the final answer should be cos 2x minus 2 sine 2x, the whole thing divided by e to the power of 1 minus x. This is a very interesting question. It might seem a bit complicated, but then if you have organized your work properly, okay, if you've identified first of all that it is a quotient of functions, and the quotient, the numerator and the denominator, both of them are composite functions, which means to find the derivative of the numerator and the derivative of the denominator, you have to use the chain rule. But finally, don't forget, you're combining both of them into the quotient rule, the formula for the quotient rule, because the original question was the quotient of two functions, okay? As opposed to the first question that we saw, the original question was a composite function, okay? Outside function and inside function, and the inside function was a product rule. So if you found this video useful, do not forget to like, share, and subscribe to this channel. I'm going to see you all in the next video.